So, like I said earlier, we're going to be looking at solving equations, solving 1 and 2-step equations. We're going to start with a very, very simple activity. Okay. So, based on the information provided to you guys in question 1, we want you to find the numerical value of the following 3 items. We want you to find out how much each drink is worth, how much each burger is worth, and finally how much each fry is worth. All right, so we are going to give you and your team the next 5 minutes to solve question 1. You're only working on question 1. Are there any questions on what you are doing with your team? Thumbs up if you understand. All right, great. You guys have 5 minutes starting now. Okay, yeah, it's time. So let's have some of you guys help me out here. So based on the pictures, how much is each drink worth? Raising your hand, how much is each? Yeah, Victoria, go ahead. 10. All right, that's pretty easy. 10. We have 3 drinks that add up to 30, so that means that each drink must be 10. 1 drink and 2 burgers. So then that means that each burger must be worth how much? Declan? 5. Well, we know a drink is 10, and if 2 burgers plus a drink makes 20, then that means that each burger must be 5. Finally, I wonder if any of you guys were like kind of weirded out by the fact that the fries, there's double fries. Jacob, what do you think? What's each fry worth? Oh, both of you guys are Jacobs, my bad. Yeah, go ahead, Jacob Martinez. A single fry is 1, but if it's a double fry, that would be 2. So like this is 5, and then we're saying, okay, this is 2 fries, so that's 2. 2 fries, that's 2. 5 and 2 make 7. 7 and 2 make 9. Very good. How did you guys arrive at the value of each picture? Let me ask group 3, Viviana's group. How did you guys arrive at the value of each picture? Like, what was the strategy? How were you able to come up with the values? Anyone from your table, if you'd like to share? Okay, so just counting, I guess. Yeah, counting how many of each item. Did anyone do anything like very mathematical, like, oh yeah, I noticed there were 3, so I multiplied by this number, or I divided by this number? Or anyone have like a different explanation other than just counting? Okay. Find the value of the following equation that is pictured. 1 burger plus 1 fry times 1 drink. What is this going to equal? Lila. 15. And how do we get 15? Very good. So here the process would be 5 plus 1 times 10. 10 times 1, like you said, would be the first step. And then 10 plus 5 is 15. Excellent. If the second line was equal to 24, so we're talking about this one. If this line was equal to 24 instead of 20, what would the value of each picture have to be? Were you guys able to come up with that one? Jacob Aguirre, go ahead. Each burger would be equal to 6? Or each item would be equal to 6? Okay, so if you're saying, I'm going to write some numbers next to it. So you're saying the drink is 6? Each of the burgers is 6. Okay, so this is 6 and this is 6. How much would the drink have to be worth? I think if we know that the drink is 10, I think it's going to stay as 10. It's just that we don't know what the burgers are worth. If the burger is 10 and each burger is 6, then this would add up to 22, not 24. So what would each burger have to equal? Assuming that the drink is 10, then each burger has to equal how much? Go ahead. 7. Because true burgers add up to 14. 14 plus the original 10 would make 24. Now, if we had to change the value of everything, then each item could be worth 8, because 8 plus 8 plus 8 adds up to 24. So there's like different strategies to this. It's kind of ambiguous. There's not enough information to determine whether we have to change all of the values or only the burger values. But we can say that one combination could be that the drink is 10 and the burger is equal to 7, or everything is 8. Okay. Now, realistically, you could pick any values as long as they add up to 24. Picking 8 just means that everything is worth the same. But you could do any combination, like the drink is 11, and then each burger is like 6.5 or whatever. Stuff like that. You can just kind of make your own as you go. Okay, we can move on to number 2 then. So you guys got some experience working with number 1. For number 2, I'm going to give you a little bit less time since you're only answering 2 parts. So you want to consider the situation below. You have 2 elephants and 4 horses working together. And we're saying that 2 elephants and 4 horses working together is the same as 12 horses working together in terms of strength. All right, so you and your team are going to determine the strength of 1 elephant. All right, take 4 minutes and see if you guys can figure this one out. Time starts now. All right, that's time. So once again, the situation was the following: 2 elephants and 4 horses together are the same as 12 horses. What'd you guys find out about the strength of the elephant? 1 elephant is as strong as how many horses? With your hand, show me a number. 4, very good. So 1 elephant is as strong as 4 horses. Now I'm very curious to find out, how did you guys come up with this number of 4? Viviana. Okay. So like, you're saying, okay, these 4 horses and these 4 horses, I can take them away, and then you're left with how many? Oh, okay. Then that means that each elephant must be worth 4 horses. Very good. All right, so I'm going to put that into writing. What Viviana just said, I'm going to write down. So you take away 4 horses from the left and 4 horses from the right, and then divide the remaining 8 horses on the right by 2, to find out how much each elephant is worth. No, not is worth. Is equivalent to. Okay. All right. So it is. You take away 4 horses from the left and 4 horses from the right. That means you are left with 8 horses. And then these 8 horses you split in half to find out the strength of each elephant. That is what Viviana said. Okay. All right. Moving on to the next part. Suppose 3 lions and 4 zebras working together had the same strength as 13 zebras. What would the strength of 1 lion be compared to the zebras. So how could we go about this? Let me draw. I can't draw a line, but I can try. Like in red, like let's say this is a lion. We're saying 3 lions and 4 zebras are the same as 13 zebras. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. How could I come up with the solution for this problem? Do you guys think it's a good idea to use the same strategy from earlier, the same strategy that Viviana used? Should I do that? Okay, so if we went ahead and did that, then what am I going to do with the 4 zebras on the left? Am I going to add 4 zebras to the right, or what am I going to do here? Go ahead. I'm going to subtract these. I'm going to get rid of each one of these, and I'm going to get rid of the same number on the other side. Now that leaves me with 1, 2, 3, 4, 5, 6, 7, 8, 9 zebras. We're saying there's 3 lions remaining and 9 zebras on the other side. So how could I find out the strength of each lion? If I have 9 zebras total and 3 lions, then what could I do here? I could make groups of 3. I could figure out how many zebras can I fit into one group so that I can get 3 even groups, and then I can say that each lion is worth that. So I can make a group of 3. That's 1, that's 2, and then that's 3. And so if we split up each group corresponding to 1 lion, then we're saying that each lion is equal to 3 zebras. That is what we're saying. Now, just for reference, in red with the little ears, that's for the lion, and then the blue dots or the blue circles, that represents the zebras. Okay. So we're just concluding here that each lion is equivalent to 3 zebras. All right. Are there any questions on how I came about this solution here? All right, now it would be nice to continue working with visual representations, but we are going to move on to actually looking at some variables. That's what they're called, like the letter X. When we don't know the value of something, we tend to denote that unknown value with a letter, like X or Y or even Z. So as we make our way throughout this lesson, you're going to see that we're going to change the visual representations with the letter X. So we're gonna do one of these together, so you guys get an idea of what it is that I want you to do. Because now we're going to find the missing value of X. So the instructions are the following. For these situations below, find the lengths of the missing pieces. Just for reference, any missing piece is going to be denoted, or is going to be shown as a letter X. That's a missing piece. Make sure you can explain in detail how you found the missing length. I'm not going to require you guys to write it down, but if while you guys are working on this, if I come to your group and I kind of ask you guys to explain it to me, please be prepared to show me how you got your solution, okay? So let's do the first one together, and then I'll have you guys break off into your groups and solve the rest of these. All right, so we have a length here at the top and a length here at the bottom, and we know that the bottom length is equal to 32. So then how could I figure out the missing length at the top? Given that I know this section is 10, how could I find X? Jacob Martinez, go ahead. Okay, so we're saying like this much is 10, right? So to find out the sum, I would have to add these. X plus 10 equals 32. If I'm working backwards, I could subtract 32 minus 10, and that'll give me X. What is 32 minus 10? 22. So we're saying that this piece over here must equal 22, so that the sum of 22 and 10 adds up to a total of 32. You guys kind of see what we're supposed to do? I mean, it's pretty simple, but we just want you to make sure that, we want to make sure that you understand this idea of finding a missing value. I don't know if the rest of these will be as easy as the first one, but I think you guys can do just fine with one another. So take about 8 minutes to complete 2, 3, 4, 5, and 6. So the rest of this, you have about 5 problems, and let me give you 8 minutes. You guys can go ahead and get started. All right. So let's take a look at the second one. In case you were stuck on the second one, I forgot to tell you this, but you are able to subtract quantities that are given to you. So we don't know what x is yet, but if you're given any other numbers, you can subtract those from the original amount. So for example, this 8 here, I know that this section here must also be 8 to be equivalent, to be the same. Now, what we are also kind of saying here is that this 8 plus something else adds up to 44. So what is this other missing quantity? What number plus 8 will give you 44? Think about what number plus 8 gives you 44. Go ahead. 36. Okay. So really what we're trying to find out is, what is this section going to be if it is equal to 36? X plus 2x equal to 36. So how can we find out the value of x? Well, we can do the following. How many groups of x do we have? We have one unknown plus 2 more of the same unknown. So in total, how many groups of x do we have? We have 3 groups of x. So we're saying we have 3 groups of x, and that is going to equal 36. So if 3 groups of the same size equal 36, then what must each group contain? Gianna. Go ahead. Yes, 12. Once again, we get 12 because if we have 3 groups of the same size, the key word here is equal size. You can't have one group have 10, the other group have 14, and then the remaining group have whatever's left. No, because then they're not the same size. 3 groups of the same size that are equal to 36. That means that each group evenly must have 12. Okay, so that's how we find that x is equal to 12. Now, this idea of subtracting from below, we can apply with variables as well. So it's not something that we just have to do with numbers. We can also do with variables. For example, look at number 3. We have y and y equals to 25 and y. Now, this length here and this length here are the same. And because they're the same, we can actually get rid of them. All right, think about earlier when we were looking at the horses analogy, the horses activity. You had 4 horses on one side. That means you can take away 4 horses from the other side. In this case, it's the same. One length on top and one length in the bottom. You can kind of make those go away. So here we're looking for 2 equal size groups that make 25. If I'm looking for 2 equal size groups that make 25, then what must each group contain? Gemma. 12.5. Once again, 12.5, we're looking for 2 equal size groups that make 25, that add up to 25. All right, let's continue. 2 equal size groups of x plus 3 is equal to 25. So now we're saying this little bit here is 3. So what must this other half be worth? If that little bit there is 3, what must the rest be worth? If it has to add up to 25, 11 and 3 would make 14. Everything, yes, just this part right here in red. 22. Good, good, good. Yeah. Or you give me the final answer, yes. Okay, so this right here is 22. Now then we're looking for two equal size groups that make 22. Then you are correct, Elizabeth. Each group is 11. Each group is worth 11. Does anyone have any questions on how I'm getting 11? Okay, let's continue. Two equal size groups and 4 make x and 16. All right, this and this amount, since they are the same, I can cross out. So really, I just need to figure out this amount and this amount. Now, if this little piece is 4, then we can find x by just looking for the remainder. What number plus 4 is going to get you 16? What do we think? Fabian, what do you think? What number plus 4 is going to get you 16? 12. So that means that x is equal to 12. Okay. Last question. 2x plus x plus 7 equals 25. So same idea. We begin by looking at the amount that is the same and figuring out the remainder. So if this little bit is 17, then the rest of this is how much? Let me hear from people I haven't heard from yet. Once again, if this piece here is 7, what must the rest of this be worth? It has to add up to 25. Xavier, what do you think? 18. Now we're looking for 3 equal size groups that make 18. So 3 equal size groups that make 18. What must each group be worth then? Gael, what must each group be worth? 3 equal size groups that make 18? Think about it. Three equal size groups that make 18. So each group has to be the same amount, same number. Give me a number. Give me a guess. You want to try a number? Pick a number. Any number you want to pick. We'll try it. Just pick a number. You want to start with 5? We start with 5. 5, 10, 15. We're 3 numbers short, so 5 doesn't work. Go higher. 6. 6, 12, 18. That means that each group is 6. Okay? All right. So, this is, we're going towards like finally getting to that step where we can actually do some 1-step and 2-step equations here. So that's what we're going to do in the next part. I'll walk you through some notes, and then that's going to be it for notes. We'll get you guys your break, and when we come back from the break, you'll just be working on your homework. Okay? So let's talk about the ways to communicate algebraic thinking. So now we're going to translate the picture and description into some equations. Thinking back to the beginning, we looked at the 3 drinks and how they add up to 30. Well, in this case, I'm going to label drinks as the letter D. So that's D plus D plus D. As an equation, I have 3 D's together, right? 3 D's together that equal 30. 3 D's together equal 30. And how do I get 3 D's? I get 3 D's by adding, 3 D's together. 1D plus 2D plus another D makes 3D. 3 D's together, if we want to solve this, then I would need to divide. Since I'm currently multiplying 3 times whatever D is worth, then I simply undo that step. The opposite of multiplying by 3 is to divide by 3. So naturally, to get D by itself, I have to divide both sides by 3. Now, this idea of what you do to one side, you do to the other, you have to always remember. You can't manipulate an equation on just one side. It's a balance. You have to do the same thing to both sides, otherwise the equation will be off balance. Okay? All right, thinking back to the elephant and the horses. We have 2 elephants plus 4 horses, and that's equal to 12 horses. Now in this case, I don't want to have two different variables. Let's just leave it as 2 elephants plus 4. The 4 is going to represent the horses. The 12 is going to represent the horses on the other side of the equal sign. So to solve this, 2e plus 4 equals 12. You're first going to begin by subtracting the horses. And this is a step that you guys told me about. You guys have to do this first step. You can take away the same quantity on both sides. So 2 elephants would then be equal to 8. Once again, 2 elephants would then be equal to 8. And if we have 2 equal size groups that equal 8, then that means that each group is equal to 4. Right? Each elephant must be equal to 4 horses. All right. The reason why I didn't do E's and H, like E for elephant and H for horses, is because that's not something we teach you until later on. Solving a system of equations with 2 unknowns. All right. Moving on to the material that we just looked at right now. So the length, we have 2 times the unknown length of x plus another x plus 7, and all of this is equal to 25. Well, we can put this all together. 2x plus another x makes how many x's? Once again, you have 2 x's, you add one more, you get how many? Now you have 3 x's. So we have 3 x's plus 7 equals 25. 3 x's plus 7 equals 25. And if I have the same length on both sides, I can get rid of it to find out the unknown. So that means 3x will equal 18. It's the difference. So again, 3x will equal 18. And I'm looking for how much I can fit into each group if I want 3 equal sized groups that make 18. And this was going back to what we just did with Gael. So this is 3 equal sized groups that make 18 means that each group must have what? 6. Okay. Last one. So x plus 4 equals x plus 16. Once again, x plus 4 equals x plus 16. I can combine the x's, and that's going to give me what? 2 x's. 2x plus 4 equals x plus 16. Now we're gonna do that step like how we did earlier, where you can subtract the amounts, right? So if you have the same amount on one side and the other side, you can actually take it away. I'm going to take away 1x from the left and 1x from the right, and that's going to leave me with x plus 4 equals 16. So we are down here. You take away the x on both sides, and you're left with x plus 4 equals 16. So then to find out the value of x, I'm looking for some number plus 4 that will give me 16. So what number plus 4 gives you 16? There's a very easy way to figure out exactly what number, and that is to work backwards. You take away 4 from 16, and you get what? You get 12. Okay. All right. So, are there questions on how we came up with these equations? These are the algebraic equations. So this is more of what you are going to see in this class. We won't really, show you pictures. This is what you would probably see in like 7th grade, the pictures, stuff like that. For us, we're going to focus on solving algebraically. Okay. If there are no questions, then I'm going to give you guys your break. We're going to come back at 12:05, and you'll have an assignment to do. All right. Get your cell phones.